So hi friends, good afternoon again. So here I come with a new problem which is repeated so many times in the examination. So in the question, the same thing again. We need to determine the coordinates of centroid for the given section. Now whatever the section you see here, the height of the section is given as 50 millimeter, and the total width of the section it is 20 plus 40 plus 20 is totally 80 millimeter. Now for this section we have to determine the coordinates of centroid. Now the first thing is we have to assume that the section is in the first quadrant, or you can also assume it to be symmetric about y-axis. But for my convenience, I'm assuming it to be in the first quadrant. Whenever you assume it to be in the first quadrant, that means its x-axis will be exactly to the base, I mean to say at the bottom, and y-axis will be towards the left side of the section. And assume that there is a point capital C whose coordinates are x bar and y bar, which is nothing but the centroid for the given section. Next, coming back to next step, second step. Now divide this entire section into number of geometric sections. Now it can be divided into four different sections. Now here you can clearly see that it has got a triangle over here, next a rectangle in the middle, one more triangle, as well as a semicircle which is being removed from this entire circle section. A semicircle which is being removed. Okay, now here I have drawn all the four different sections, right? The first triangle, I'm just designating this one as the first triangle. This one, the first triangle. Next, in the middle, we have a rectangle. This entire thing, it is a rectangle. And towards the right side, we have triangle number 2. This is triangle number 2 here. And from the rectangle, a semicircle is being removed. So I'm just drawing the semicircle, which is removed from the rectangle. Now, step number 3. Let us assume that there are four different points C1, X1, Y1, which is nothing but the coordinates of centroid for the triangle 1. That means let us consider it to be C1. This point here, it is C1. Next, let us assume that there is a point C2 whose coordinates of centroid are X2 and Y2. This is for the rectangle. Similarly for C3, it is for triangle number 2, and similarly for C4, it is for semicircle. Now, to make it clear and to determine the coordinates of centroid for each of the triangle, rectangle, and the semicircle, I have drawn them individually. As you can see here, right, we have an x-axis and a y-axis, and I'm just considering the first triangle here, right? The first triangle, it has got a base of 20 millimeter and height of 50 millimeter. I'm assuming that it has got a center C1 whose coordinates are x1 and y1. X1 refers to the distance from the y-axis, reference y-axis. Y1 refers to the distance from x-axis. Similarly, I'm considering the rectangle. This rectangle, it has got a point C2, which is nothing but the centroid for the rectangle, X2 and Y2. X2 is the distance from reference y-axis, and Y2 is the distance from reference x-axis. Similarly, we have the second rectangle, rectangle number 2. It has got the coordinates C3, X3 and Y3, where X3 is the distance from reference y-axis again, and y3 is the distance from reference x-axis. Now at the last we have a semicircle. For this semicircle there is a point C4 which is the centroid for this semicircle, which is removed from the rectangle. Now the coordinates of centroid are x4 and y4. X4 is the distance from reference y-axis, and y4 is the distance from reference x-axis. As we all know that for any triangle, the coordinates of centroid will be located exactly at a distance of 1/3 of the height from the base and 2/3 of the height from the apex. And in the horizontal direction, again it is divided into 1/3 as well as 2/3. Now over here for the first triangle, right, x1, the distance x1, right, it can be written as this particular distance here. It is x1 is equal to 2/3 of the base from the sharp edge. I mean to say from this point, it is located exactly at a distance of 2/3. That means it is divided into three parts. Exactly at the second part, I mean to say this is divided into two parts, as well as this one is the third part. So x1 will be equal to 2/3 of 20 millimeter, and y1 will be 1/3 of the height. 1/3 of the height, I mean to say this is 1/3 of 50 millimeter. Now the coordinates x1 and y1 will be 13.33 millimeter and 16.66 millimeter. So C1 x1 comma y1 will be equal to 13.33 and 16.66 millimeters. If I take A1 as the area of the triangle, A1 will be equal to half multiplied by base multiplied by height, which will be equal to 500 millimeter square. Now coming back to the second one, the rectangle, as we all know that x2 is the distance from reference y-axis, right? It can be calculated in an easiest manner. So for this rectangle, this point is located exactly in the middle. I mean to say that will be exactly half of 40. That means this particular distance it will be 20, and the remaining part it is 20 millimeter. So x2 can be written as 20 plus half of 40. So x2, which is equal to 20 plus 40 divided by 2, which is totally taken as 40 millimeters. And the same thing again, y2 will be half of 50. Y2 is equal to 50 divided by 2, which is equal to 25 millimeters. And if I take A2 as the area of the rectangle, A2 will be equal to 40 multiplied by 50. That is 2000 millimeter square. So this is 2000 millimeter square. Now coming to the third triangle, the third element, the third triangle. So C3, X3 and Y3. X3 is the distance from the reference y-axis. So we can calculate it very easily, right? We all know that it will be located exactly at the distance of 1/3 of the base, that is 1/3 of 20. This particular distance is 1/3 of the 20 plus 60. We need the total distance up to here. So if we require this total distance, it will be up to here it is 60, and the remaining part will be 1/3 of the 20. So I'm writing down here x3 is equal to 60 plus 1/3 of 20. So 1/3 of 20 plus 60, that will be 66.66 millimeters. And similarly y3 will be equal to 1/3 of the height of the triangle, that is 1/3 of 50, which is equal to 16.66 millimeters again. So I'm writing down those values here. X3 comma y3, that is C3, which is equal to 66.66 and 16.66 millimeters. And the area of this one, A3, the second triangle, it will be same as the first one, that is 500 millimeter square. Now coming back to the last one, the semicircle. As we know that for the semicircle, the centroid is located from the base at a height of 4r by 3 pi. So that becomes y4. Y4 will be equal to 4r by 3 pi, whereas the radius of this one is given as 20 millimeter, that is half of the diameter of the circle, semicircle. And x4 can be written as the distance from the reference y-axis again. So it will be half of 40 millimeter, that is 20, and the remaining 20 again. So that will be 20 plus 40 divided by 2. So totally it will be 40 millimeters again. So this can be calculated as 4 multiplied by 20 divided by 3 pi. So it will be equal to 8.48 millimeters. So I'm writing down C4 x4 comma y4, which is equal to 40 comma 8.48 millimeters. And A4 is taken as area of the semicircle. As we know that area of semicircle will be equal to half of the area of the circle. So we can directly calculate that one. So that will be pi r square divided by 2. So that is equal to 200 pi. So it will be 628.31 millimeter square. Now writing down all these values to substitute them in the formula once again. So for easy and quick solving of the problem, I have drawn a table over here which is showing the geometric section, the dimensions, area, xc and yc. The first one which I am considering here is the first triangle. The dimensions of this triangle are the base b1, which is equal to 20 millimeter, and the height h1 is taken as 50 millimeter. Now for the next one, the rectangle, the base, I'll take this one as capital B and capital H, right? Let me take this one. B is 40 millimeter, and the height of the rectangle is taken as 50 millimeter. It is given actually. Next we have B2, the second triangle, B2, the base is again 20 millimeter, and height H2 is again 50 millimeter. And for the last one, the semicircle, the diameter capital D is given as 40 millimeter, or the radius of this one is taken as 20 millimeter. Obviously it will be half of the diameter. Next, coming back to the areas, the area of the first one, right? So we have already calculated them. It is 500 millimeter square, the first one, and for the rectangle it is 2000 millimeter square, and for the next triangle it is same as the first one, 500 millimeter square, and the last one, so A4, it is equal to 628.31 millimeter square. So this is A1, this is A2, this one is A3, and we have A4. Now, as we have calculated the coordinates x1, y1, x2, y2, x3, y3, and x4, y4, I'm going to represent all the values over here. The first one, it is 13.33, x is 13.33 millimeters, and y, it is equal to 16.66 millimeter. This is y1, this is x1. Next, same thing again, x2, which is equal to 40 millimeter, and y2 will be equal to 25 millimeter, and x3, it is equal to 66.66 millimeter, y3, which is equal to 16.66 millimeter, and x4, this x4, it is equal to 40 millimeter, and y4 will be equal to 8.48 millimeter. I'm not writing the units over here because I have already indicated the units exactly at the top. Now, we all know the formula to calculate the centroid of any plane figure, right? That is capital C x bar come y bar, which is equal to sigma ai xi divided by sigma ai, and sigma ai yi divided by sigma ai. Here, expanding the formula, x bar is equal to sigma ai xi divided by sigma ai. Now here you have to remember that from the sketch which we have drawn in the previous one, right? This one, there are two triangles along with a rectangle. Now from these elements, right, there is a semicircle which is subtracted, so in the formula we should be very cautious. So we have to write the formula as a1 x1 plus a2 x2 plus a3 x3. Now here comes the semicircle, it is a4 x4 divided by a1 plus a2 plus a3 minus a4. So why did I take a minus here? Because from the entire section semicircle is being removed. Now I'm substituting the values. Now a1 x1 plus a2 x2 plus a3 x3 plus a4 x4. Actually this should not be plus, intentionally I have written as plus, it has to be minus. This one should be minus, just remember this one. Substituting the values and calculating, we will get the value of x bar, which is equal to 39.99 millimeters. Similarly, calculating y bar is equal to sigma ai yi by sigma ai. So that will be a1 y1 plus a2 y2 plus a3 y3 minus a4 y4 divided by a1 plus a2 plus a3 minus a4. So as we know that the value of a1, it is given as 500 multiplied by y1 is 16.66 plus a2 is 2000 multiplied by y2 is 25 plus a3 is 500 multiplied by 16.66 minus a4 628.31 multiplied by 8.48 divided by 500 plus 2000 plus 500 plus 2000 plus 628.31, a1 plus a2 plus a3 plus a4. There is no 2000 over here and it has to be minus again. Now calculating the value of y bar is equal to 25.86 millimeters. So finally we got the answer for the given section, capital C x bar comma y bar, which are equal to 39.99. Obviously you can take that one as 40 millimeter, and 25.86. 39.99 and 25.86. Thank you very much.